All right, we're back. So we're back on stage, and if you're at home, I hope you're back. So we're gonna start the last of the last. So the last block of sessions on the last day of our Automation Developers Day. And I'm very happy on the topic of the next session on the development that Cisco is doing, because every time I go to a customer, one of the key things they ask me is, if I have 2 points in my network, can you show me the actual real path that is taken? So I'm happy that we have now some answers for them. So I'm happy to present Sujay and Amish, who's going to walk us through these great features regarding routing, analytics, PCA, CNC, and how we solve this great problem. Thank you.
Yep. Thank you, guys. So Sujay kindly offered me a chance to share the IP measurements as part of this story. So that's what I'm going to start with. So we're going to talk to you about optimizing network performance, and troubleshooting with CNC, routing analytics, and IP measurements. I'm mainly going to cover the IP measurements portion, is onto basically how you provision them, what's happening in the back end, and also talk about beyond the transport network. So basically, even when services terminate, for example, on custom premise equipment, how you can even measure those with active probing. So then Sujay is going to tie everything together with CNC and show you pretty much use cases as well in terms of the optimization using CNC, routing analytics, and the IP measurements. Yep. All right. So automating IP measurements. So to start with, let me paint the landscape for you guys. So pointer doesn't work. It's fine. So what we're going to be talking about today is, I'm going to point on the screen. I'm going to be talking to you about this IPM session here that will test pretty much across all ECMP paths. We're going to be talking mainly about the spray method, how to configure this, and then also how to configure pretty much this session that goes from this C end to the C end. And usually, you would test pretty much the A to Z to be able to offer visibility to your end customer on basically the performance of what they bought. And then for your P to Q, for example, it'd be something more operational that you'd be looking for to see if there's any issues there. And then we have RA. What RA does is it tells us what's expected pretty much in here across all the ECMP paths. We measure basically the customer experience from P to Q and A to Z, but we can also now have an idea of what is happening routing-wise and what's expected across the ECMP paths. So I'll show you basically an operational view of how you can pretty much isolate whether the issue is at A to P or with one of the expected or unexpected, I should say, ECMP path performances between P to Q with pretty much the correlation with IPM. So again, we're going to talk about the configuration of IPM. We're going to talk about the end-to-end session configuration at first, and then I'll have a little bonus at the end too. All right. So in terms of what you saw in the presentation this morning, if you attended Tom, Deepak's, and Yannick's presentation, they showed you the example of provisioning pretty much the IPM session between Seattle and Berkeley. And here, the sender basically was Seattle, and the receiver was Berkeley. So sender P, Seattle, and Berkeley Q. And both of them are running pretty much forwarding the packets on an IPv6 forwarding plane. And there's a bunch of information and data that is part of that service, such as metadata that's being passed. You can see the monitoring profile up there, which is the layer 3 VPN gold, there's different aspects to it as well, because based on distance, you can have different profiles for your histogram as well. So I'll talk through those things. All right, so how does it really work? Well, I've got an army of minions basically behind the scenes that's doing this. My niece, she's about 8 years old. She asked me, "What do you do and how does this work?" The quick answer is basically a bunch of minions that work behind the scene to get stuff done. I thought, I'd kind of lighten the mood in the afternoon. Everybody's tired, but let's get into business. All right, so here, what we're going to do is we're going to take the sender, so P, where all those OAMP sessions are being pretty much orchestrated. And what's important to note here is I've highlighted them in purple. So you've got two modes that you can actually set up, either loop back or one-way. So for example, if you've got synchronization in your network, do the one-way, and you'll get much better pretty much view, because as Yannick was explaining this morning, especially with liveness, packet loss, you can detect asymmetries basically with that. And then the other one is you can also look at the rate at which you want to send your test packets. So for example, for the NPU on the Silicon One, 999 microseconds pretty much intervals. Then you can also use your setup to mark the packets. So set up your DSCP so that it follows the right pretty much marked traffic. And for the flow label, then this is where you choose. So if you want to go across all the ECMP paths, you would actually spray. But if there's one particular path that you want to go through, you can assign basically which flow label you want the test to run over. And then the endpoint is that you define here, and the verf is proper to the service. But for the endpoint address here, that's the queue, basically receiver side that you're defining. Then we have to look at the receiver side. So that's the sink, which is receiving all of those OWASP packets that you've just configured. Here, as you see, the IPM receiver profile, you put down the expected probe interval. We had chosen 999 microseconds for the NPU, so the default level. Then the next one is to point out, which is kind of important here, is the histogram template. So you can imagine that when you're going, for example, from a metro region that's about 100 kilometers long, the expected latency or the latency that you would think you would get would be possibly in the mid to maybe high single digits. And then when you're going pretty much across the sea and through two continents, it could be double digits, if not close to high double digits in some pretty much cases. So this IPM profile, what it does is, the histogram template, what it does is it makes sure that you're setting up the bins in which those probes are actually being recorded against, so that it's, when you get your histogram, it's actually uniform. You don't get a skewed pretty much mean because you didn't choose your bins distributed well. And those templates, there's going to be a few that's going to be provided, for example, international, local, etc., that based on use cases, we already know pretty much what to expect and how to center those mean measurements, or modal measurements, I should say. And then the last thing that I want to cover here is the endpoint that you define here, again, is pretty much the sender endpoint. All right, now what do you expect to get from Q? So over pretty much MDT, you'll get the continuous time series of the histogram latency, the packet loss, and the liveness. And you can also have a setup basically for liveness in terms of EDT. And here, of course, you'll get your session ID, your VERF, all this metadata pretty much that came when you were provisioning the service. Next thing is about configuring this A to Z. That's basically what's hanging behind the P2Q. So the model here, as you see, is you've got pretty much the grouping, which we call service. Then we've got the nodes sessions, and then we've got the service endpoints. So here I'm showing an example, basically, and I'm going to focus on only one session, which is pretty much here I'm showing some PCA sensors. We've got the sensor SFP, and we've got some software sensors, which are agents. And I'm going to focus on how to provision one of the sessions. So first of all, in the service model, we're going to take care of provisioning endpoint A. So this endpoint A is, you'll define it some metadata, which is the type, the name, the geolocation, the ID config, the VLAN ID, and the IP as well. Similarly, you'll do the same thing on the Z point. Of course, the VLAN ID will be the same. And then for the session itself, the session that we're going to actually execute will be the active continuous testing with TWAMP Lite. So the session that, metadata again, the session name, and then the session type will be TWAMP Lite. And we've got some metadata key value as to what kind of service this is here, residential. And then we're going to define basically the service endpoints as part of this session. And we're going to have the protocol definition underneath as well. We can set up pretty much the packet rate as well, as you see, in terms of that session protocol pretty much definition. Then the service itself grouping has some metadata that you can attach to it as well. Here, chosen region. And the other thing that I can define as well as part of this service grouping is alerts. So this is the bonus that I was talking about. Great, you're measuring. You can stare at a dashboard, super. But now how do you get more proactive? This is where we've introduced a way for you to, when you're provisioning the service, to be able to also provision the assurance at the same time, and then more, which is provisioning pretty much an alert for when an SLA is violated. And this is where you see the alert policy endpoint here. This one is packet loss alert. Coincidentally, the example that I'm going to show basically for that part is actually packet loss as well. And the policy conditions, such as the threshold you can set, the comparator greater than, and so on. So those are the and the type as well. You can either go metric or baseline. So we've got two types of alerts that we support in PCA. So how does that first part that I was talking about in terms of provisioning the session, basically A to Z, work or translate in PCA? So the service session and then the service endpoints, this is what it translates to. So we have an inventory. It ends up pretty much cataloged there. Here, I'm showing a TWAMP SF basically session. We've got the source lat long and target lat long, which are part of the endpoints that we defined. And then the type of service that we defined was a residential service, and the names of the reflector and sender that we defined was endpoint 1, endpoint 2. The region, if you remember, as part of the service again, was Nordics, and the service ID and service name, which were at the top of the header for service, was example service, example service. So this is how it ends up. And why is this important? It's because when you're doing analysis, you can actually club or group by on metadata. When you're setting the alert as well, you can alert basically and use those as filtering criteria. All right, so the alert notification integration. Again, you know, keeping on the same theme, I thought I'd add a little GIF for my little niece talking about basically how this works as well before I show the real thing. All right, so let's see. Choose content. Entire screen. Oh, it's telling me I have a meeting. Excuse me. All right. So what I'm doing here is I have an API endpoint which I was showing you basically that helps me create the alert. And what I'm doing is I'm going to show you the output basically appearing at a webhook. I'm using PipeDream, which is free, basically webhook. And what I'm doing is I'm defining pretty much the alert policy. The alert policy is that alert that I created has a unique ID which you can fetch basically from the analytics. So I already created it to save a bit of time. So what I'll do is I'll actually patch it to turn it to true. That basically says fire these alerts to this webhook. So let's take a look. We should see some events. Okay. Appearing. So I'll show you an example of one that already appeared. So as you can see my screen. So the alerts that we show doesn't only show that an alert has been raised. What you get as part of it as well is a bunch of metadata. This helps you identify what service has been affected. So here, if I show you pretty much the JSON payload, what you're going to end up seeing is pretty much the equipment type on which the service was, the region the service was affected, the type of metric that was violated, the source city, you've got the longitude and latitude. There's a bunch of other details as well, such as the actual name of the service, the policy type. There's also some timestamps associated to it that tells you when the alert was raised as well. So, and here I've got an array, basically linear flat model of the topology that the service was going through as well. So this is pretty much what it looks like. You can see 359.49, sorry, that's the most recent one that fired, and it was a clear. But it's the same story. I just wanted to show that, you know, as we're speaking, there's a bunch of alerts that are being fired. And what it looks like basically in analytics is this packet loss alert that I provision. Basically, you can see and follow basically all of them that are being fired right here in near real time. Okay, so I'm going to hand it over to
All right.
Sujay?
So can I go back to the slides, please? All right. So I know that we've seen this, the export alert. So let's. All right. So the CNC RA orchestration, right? What Amish covered here about the initial intent is how do you set up those probes for the IPM session on the routers with respect to endpoints, what's created, and eventually with respect to alerts that is translated or sent back to CNC, and what are the APIs that from Crosswork RA that PCA consumes. So I'll cover in this use case on how these entities are built. The focus point is towards how routing analysis within CNC is hosted as an RA application, and what are the paths that the PCA streams will get for the paths, how you can subscribe and register to the paths from CNC, and then how the alerts from PCA is sent back into CNC, and then you can mitigate based on certain actions that is embedded with the Crosswork workflows. So I'll touch base upon how the Crosswork Network Controller RA APIs function. Today, for example, this is a snapshot of a topology where you can visualize your FlexAlgo member and the nodes, right? And what the Crosswork path analysis container contains is a companion process within the Crosswork instance, where you collect through the SRPC connection the details from the DLM for request, response, and notifications. The path updates and the metadata is transferred back up. There's a path analysis process that's running within the Crosswork path analysis application. And this is learning the BGP-LS feeds from SRPCE. So it sends this path updates via gRPC to PCA, and also updates for any changes when the path is requested or subscribed between those two entities on a specific color or a FlexAlgo. So those are imbibed with the Crosswork infra notifications. So as you subscribe and register, those notifications are sent and received. What I'll cover is also through a demo, but to start with, what is the example use case where you request or register for a path? So for example, in this use case, I'm saying that I want to request for a path between two nodes, that is SR71 and SR72, on a color 131. The request is you register the paths first to say between which two endpoints in the IPv4 encoded bit integer, and then what is the color that you want to send the paths from. You will subscribe to these paths. So you subscribe to these paths, and as you register to them, you will start receiving those notifications from the path analysis streams, which is telling about what is the color, what is the path operation state, whether the state is update is stable enough with respect to the path analysis, and it'll also give you the continuous notification or send you upstream on these details. So to showcase this, I'll show you through a quick demo. Can we switch to the monitor, please? Yeah. Thank you. Awesome. All right. So this is the example of the topology that I mentioned, right? So I'm kind of looking at the member nodes, the details of the network. And where I'm now trying to start is a register for a path between two entities and start the subscription. So I'm starting a subscription on the left pane to say between source and destination for the given color. And on the right-hand side, when I register for the paths, I can see that I receive these subscriptions or from those registered paths between two member nodes and the color. This tells me that the same path update operation state is stable between which source and destination. And I can also see along with that the other metrics, like the propagation delay for min and max, the unidirectional delay. And as I have registered for the path, I can also unregister them to stop receiving the subscriptions. So it's an ad hoc request. You could send, register for the paths, receive the subscription, and once it's done, you'd see on the left-hand side that this subscription event has ended. So you can subscribe for any endpoints between two head ends or destination, and then you can also visualize for the color or the FlexAlgo between those member nodes.
Switch back to the slides.
Yeah, so can we switch back to the slides? Yeah, so this was a snippet into what is being developed. I know the RA APIs functionality is what is hosted in Crosswork. Through the alerts, now that Amish has shown how the alerts are sent back and how that can be subscribed. So the next intent is on how do we enhance these use cases with CNC. As Deepak, Yannick, and Tom today, this morning session, they focused on what are the use cases also. And with routing analysis, traffic engineering and optimization, that is any user that relies on the streams or path analysis network to identify what are the traffic engineering use cases that they want to create with what metrics. Service and transport for topology mapping between your services, visualizing them on your service layer. And finally, enabling with closed loop automation with respect to where there is a degradation. Can I get more data or granular data to understand what are the impacts or a future degradation that is possible within the service? So when CNC reports this service degradation, it's highlighted as a possible cause, and to the underlay subservices, the user contextually cross-navigates that to PCA and performs the analysis on the PCA side to view more details. And he can click on that details to analyze, okay, what is the path? Now, this is a cross-launch, but of course, to say that for those specific entities between those two endpoints, what is the degradation? What is the potential causes of failure? And you can analyze between the root cause analysis is to say this is a potential degradation on this service coming from PCA as a source. Finally, with embedded workflows, I can, once this is initiated, I can request that through the workflow to take an action, mitigate on those actions for those use cases or those paths where I could exclude certain links through the workflow, and then also identify which links that I want to include or exclude as part of the IGP, and do continuous monitoring based on the SLA that is attached. With service health, the objective is also once you analyze, you could contextually attach to your new SLA rules that says, okay, if there's a violation of a latency, I want to apply a new rule to the service so that I can continue the service assurance with the newer SLA so that it monitors based on whatever the state of the service is, and that could potentially cause a degradation in the failure. So this is eventually what we've shown today is what is upcoming in CNC and PCA. Of course, there's more integration work to be done. But so far, this is more of the prototype, and as you have seen, we would love to get your feedback. So feel free to reach out and let us know how we can discuss and engage more for these use cases.
Okay, very well done. Thank you very much. So let me ask you a question. So you just mentioned this is upcoming, correct? Can you just reiterate where we are, where we think we're gonna have this in both cases in the products?
Yeah, good question, as acknowledged in the audience. So, yeah, this is for CNC. We are looking at integrating, building the RA will be hosted on CNC in the upcoming release of CNC, potentially not in the committed phase, but probably in 7.2 and beyond. And the exposure of RA APIs, what I demonstrated, is potentially would be available once.
Great. So we are, if we want to change the encoding of the IP addresses to have actually the normal encoding, that's we still have time to give that feedback. Yep. All right.
We're working in lockstep with basically Sujay and his team and Deepak. So we're also going to land around the same time frame with the integration of RA and IPM. My colleague Yannick is actually in the audience, and I hear whispers of FCS being around towards the end of the year, so that's when you can expect to have it. But that being said, I mean, you can still pretty much do a lot of what we've talked about as well, pretty much with other measurement methods and so on. So you can already get started, and by the time we get there, we can help you basically bring that in as well.
Yeah, sure, because at the end of the day, as we develop these new technologies, it's also a journey because the network needs to be upgraded, etc. No new hardware. We just going to work with what we have, but we can upgrade, create, work with what we have, and as we get the new technologies in place, we can actually improve the troubleshooting and reduce the time frame. Yeah. All right, I take this also as part of our journey to create this digital twin, correct? So
Correct.
more information about the topology, about the path, simulations, these sort of things that we can actually go connecting to AI, connecting to autonomous network. This is part of what we need.
You're getting a better model, basically, of what's in your network with the tools that we're talking about here. So basically, you're covering the ECMPs, not just the end-to-end, and also being able to see what you expect in terms of routing.
Yeah, and are you having conversations also in other domains like data center on the same idea of measuring ECMP path, etc.?
So I know with Yannick, he's the expert here, but can I have you up on the stage, Yannick,
No.
or just to mention, basically?
All right, so the short answer is yes, and we need that for fabrics connected to AI. Absolutely. All right, thank you very much.